Good morning, students. It's continuation of our lecture. Today we are going to discuss on effect of pH on different textile fibers and sequestering agents. Effect of pH on different textile fibers. pH plays important role in dye. pH is a measure of the hydrogen ion concentration of a solution. pH అంటే హైడ్రోజన్ అయాన్ యొక్క కాన్సంట్రేషన్ తెలియజేసేదాన్ని pH అంటారు. It is used to specify the acidity or alkalinity of an aqueous solution. ఇది ఈ pH అనేది ఆ ద్రావణం యొక్క అసిడిటీ ఎంత ఉంటుంది లేకుంటే ఆల్కాలినిటీ ద్రావణీయత ఎంత ఉంటుందని తెలియజేస్తుంది. There are various factors that can influence the quality of dyeing and batch to batch reproducibility, but pH ranks as one of the most important factors. Effect of pH on dye adsorption is very important. Besides, controlling pH is very important in dye bath because its effect on the dyeing cycle. Generally, pH greatly influences the uptake of dye. In the case of acid dyeing, a low pH helps to form the hydrogen bonds that attach acid dyes to protein fibers such as silk and wool as well as nylon. ఈ pH అనేది ఒక డై మీద ఇన్ఫ్లుయెన్స్ చూపిస్తుంది. అంటే ఎలా అంటే ఆ డై ఎంత మట్టుకు తీసుకుంటుంది, దాని యొక్క గాఢత ఎంత, దాని ప్రమాణం ఎంత అనే దాన్ని బట్టి ఈ pH యొక్క ప్రభావం అనేది తెలుస్తుంది మనకు. అది ఏదైనా కావచ్చు, ప్రోటీన్ ఫైబర్స్ కావచ్చు, సిల్క్ మీద కావచ్చు, వూల్ మీద కావచ్చు, ఎక్సెట్రా. In the case of most popular fiber reactive dyes, a high pH actually activates the cellulose fiber, forming a cellulosate anion which can then attack the dye molecule, leading to a reaction that produces a strong permanent covalent bond. ఈ pH అనేది ఈ సెల్యులోజ్ ఫైబర్స్ అంటే కాటన్ మీద సెల్యులోజెట్ యానయాన్ని క్రియేట్ చేస్తుంది. ముఖ్యంగా ఈ రియాక్టివ్ డైస్ లో అది దాని వల్ల ఏమవుతుందంటే ఆ డైమాలిక్యూల్స్ అనేది ఆ రియాక్షన్ చెందడానికి మరియు స్ట్రాంగ్ గా ఒక పర్మనెంట్ కోవలెంట్ బాండ్ ఫామ్ చేయడానికి తెలియజేస్తుంది. Initial bath pH 6.5 to 7, before enzyme bath pH 4.5 to 4.7, After enzyme and aquacoron, pH 5.5 to 6. Before scouring and bleaching, pH is 5.5 to 5.8. Before scouring and bleaching is 5.5 to 5.8 without enzyme. Scouring and bleaching, the bath pH is 10 to 10.5. After scouring and bleaching, the pH varies between 8.5 to 9. Before leveling chemicals, pH 6.5 to 7. After leveling chemicals, pH 6.7 to 7. After adding dyes, pH is 6.2, 6.35. After addition of salt, pH varies 7.5 to 8. After addition of soda, pH varies 10.5 to 11. Before hot wash, bath pH varies from 6.8 to 7.2. Hot wash, the pH carries bath 8.5 to 8.7. Before softener, the bath pH contains 7.2 to 7.8. After softener addition, the bath pH is 6.5 to 6.8. pH levels for different stages of polyester dyeing is like this. Initial bath pH varies from 6.5 to 7. Scouring, the dye bath pH is 10 to 11.5. After scouring, bath pH from 8.5 to 9. Before addition of leveling chemicals, the pH varies from 6 to 6.5. After addition of leveling chemicals in wool process, wool dyeing process, the pH 4.5 to 4.7. After addition of colors, the bath pH 4.2 to 4.3. During reduction, clearing, the bath carries 10.5 to 11.5 pH. Before softener, the bath pH from 6.3 to 6.8. After softener addition, the bath of pH is 5.8 to 6.2. Okay. Actually, what is pH? What is the definition of pH? pH and the definition. pH is a measure of the acidic or alkaline condition of water. pH అనేది ఒక ద్రావణం యొక్క అసిడిక్ కావచ్చు ఆల్కలైన్ కండిషన్ ను తెలియజేసేది మెజర్ చేసేదాన్ని pH అంటే. It is a way of expressing the hydrogen ion concentration or more precisely the hydrogen ion activity. pH is defined as pH equal to minus log H plus, where H plus is the concentration of hydrogen ion, that is proton, in moles per liter. Water disassociate water disassociates to form hydrogen ion, that is H plus, and hydroxyl ion, OH minus, according to the following equation. H2O equal to H plus OH minus. At equilibrium, we can write Kw equal to H plus OH minus by H2O. That is third equation. But since concentration of water is extremely large, approximately 55.5 molecules by liter, sorry, moles per liter, and is diminished very little by the slight degree of ionization, it may be considered as a constant and its activity is taken as 1. Thus, the equation 3 may be written as Kw equal to H plus OH, that is fourth equation, where Kw equal to equilibrium constant. For pure water at 25 degrees Celsius, Kw equal to 10 minus 7 into 10 minus 7, that is 10 minus 14. This is known as the ion product of water or ionization constant for water. In other words, water, that means deionized or distilled at 25 degrees, disassociates to yield 10 to 7 moles per liter of hydrogen ion and 10 to 7, etc. The pH is usually represented by a scale ranging from 0 to 14, with 7 being neutral. pH scale అనేది 0 నుండి 14 మధ్యలో ఉంటుంది. మధ్యలో 7 అనేది న్యూట్రల్ గా ఉంటుంది. Groundwater is often found to be slightly acidic due to the presence of excess carbon dioxide. Erosion removes carbon dioxide and hence causes a rise in pH value. Some natural waters are sometimes found to be slightly alkaline due to the presence of bicarbonate and less often carbonate. Water with pH outside the desirable neutral range may exhibit sour taste and accelerate the corrosion of metallic plumbing fittings and hot water services. Environmental significance of pH. A controlled value of pH is desired in water supplies, sewage treatment, and chemical process plants. In water supply, pH is important for coagulation, disinfection, water softening, and corrosion control. In biological treatment of wastewater, pH is an important parameter since organisms involved on treatment plants are operative within a certain pH range. For example, determination of pH of water, standard pH solution for calibration of pH meter. The procedure is like this. Number one, perform calibration of the pH meter using standard pH solutions. The calibration procedure would depend on the pH range of interest. Second one, take about 100 ml of the sample in a beaker. Make sure not to agitate the sample in order to avoid exchange of gases between sample and atmosphere. Third point, insert pH meter in the sample. Allow some time for attainment of equilibrium. Turn on the pH meter and take reading. The different pH in different conditions of wet processing. pH should be scouring and bleaching bath, that is 10.5 to 11.5. Neutralization after bleaching 5.5 to 6.5. Enzyme bath 4.5 to 4.75. Initial dye bath after leveling 5.5 to 6.5. After salt 6.5 to 7.5. After alkali 10.5 to 11.2. Neutralization after dyeing, the pH varies 5 to 6. Fixing bath 4.5 to 5.5. Softener bath in cold wash 4.4 to 4.0 to 5. Softener bath in hot water, the pH varies from 5.5 to 6. Wool fabrics are often treated under conditions of varying pH in dyeing and finishing process. It is known that in air the dimensions of wool fabrics change with the amount of fiber swelling at a different region. In this work, it has been shown that a similar relationship between fiber swelling and fabric dimensions existed in water at different pH values. The diameters of merino and coriadal wool fibers in water at different pH values were measured with an OFDA 2000 fiber diameter analyzer. fitted with a specially constructed accessory liquid cell. The result showed that the mean diameters of swollen wool fibers in water varied with pH. Minimum swelling was obtained in the range of pH 5 to 7. It was found that the dimensions of wool fabrics in water were dependent on the pH. The changes in fiber diameter in water could be attributed to changes in ionic interactions between charged acid and basic groups, wool protein with variations in after completion of the effect of pH on different textile fibers, we go to next topic, sequestering agent. So sequestering agents is a dyeing auxiliaries which is used during dyeing for removing hardness of water. సో సీక్వెస్టరింగ్ ఏజెంట్ అంటే డై చేసేటప్పుడు ఒక సహాయకారిగా మధ్యస్థంగా ఉపయోగించేటువంటి సహాయక ఏజెంట్లు, వాటిని సీక్వెస్టరింగ్ ఏజెంట్స్ అంటారు. ఇవి ఎక్కువగా ఈ డై చేసేటప్పుడు ఆ వాటర్ లో ఉన్నటువంటి హార్డ్నెస్ ను తొలగించడానికి ఉపయోగించే ఏజెంట్స్ నే సీక్వెస్టరింగ్ ఏజెంట్స్ అంటారు. Sequestering agents. Next, sequestering agent is a dyeing auxiliaries which is used during dyeing for removing hardness of water. Sequestering agent అంటే ఈ డై చేసేటప్పుడు డైయింగ్ లో ఒక ఆక్సిలరీస్ గా ఒక సహాయకారిగా ఉపయోగించే ఏజెంట్లని సీక్వెస్టరింగ్ ఏజెంట్ అంటారు. ఈ సీక్వెస్టరింగ్ ఏజెంట్స్ యొక్క పని ఏంటంటే ఈ డై చేసేటప్పుడు వాటర్ లో ఉన్నటువంటి వాటర్ యొక్క హార్డ్నెస్ తొలగించడానికి ఉపయోగిస్తారు అన్నమాట. Sequestering agents combined with calcium and magnesium ions and other heavy metal ions in hard water. ఈ సీక్వెస్టరింగ్ ఏజెంట్స్ ఏముంటుందంటే దేంతో కలిసి ఉంటుందంటే కాల్షియం మెగ్నీషియం అయాన్స్ తోటి మరియు ఇంకా భారీ మెటల్ లోహాలతోటి కూడి ఉంటుంది హార్డ్ వాటర్ లో. They form molecules in which the ions are held so securely sequestered that they can no longer react. ఈ విధంగా ఉన్నటువంటి అయాన్స్ అన్ని కూడా చాలా సెక్యూర్గా ఉండి ఎక్కువ కాలం ఉండి వాటిలో ఉన్నటువంటి హార్డ్నెస్ తొలగించడానికి ఉపయోగపడుతుంది. The most undesirable impurities in fiber, common salt, global salt, caustic soda, and soda ash are the di and trivalent cautions. Example: Ca calcium, magnesium, copper, ferrous, etc. These ions increase hardness of the process bath and generate iron oxides in the bath. Calcium and magnesium reacts with alkali and precipitates as a sticky substance on the textile material. ఈ కాల్షియం మెగ్నీషియం అనేది ఆల్కాలి తోటి చర్య చెంది ఒక ప్రెసిపిటేట్స్ ఒక ప్రెసిపిటేట్ అనేది ఒక స్టికీ ఒక అంటుకునే స్వభావం ఉన్న వస్తువుని మెటీరియల్ మీద టెక్స్టైల్ మెటీరియల్ మీద ఏర్పరుస్తుంది. విచ్ క్రియేట్స్ ప్యాచీ డైయింగ్ అండ్ డిస్కలరేషన్ ఆఫ్ ది ఫైబర్. దీనివల్ల ఏమవుతుందంటే డైయింగ్ ప్యాచెస్ ఏర్పడుతుంది, డిస్కలరేషన్ కలర్ అనేది ఆ ఫైబర్కి అంటుకోదన్నమాట. The ferric oxide with cellulose and creates small pinhole on the fibers, also damages the machinery by scale formation in the nozzles and base. ఈ ఫెర్రిక్ యాసిడ్ అనేది ఈ సెల్యులోజ్ తోటి చర్యను ఉంది చాలా చిన్న చిన్న పిన్ హోల్స్ లాంటి పిన్నులు పడేంత హోల్స్ లాగా తయారు చేసి పేపర్ ను డ్యామేజ్ చేస్తుంది. To overcome these deleterious effects in the scouring and bleaching bath, adequate amount of sequestrant must be used. సో ఇటువంటి సమస్యలన్నిటికీ పోవడం కోసం స్కవరింగ్ బ్లీచింగ్ పోవడం కోసము ఈ సీక్వెస్టరింగ్ ఏజెంట్స్ అనేది యూజ్ చేస్తుంటాం అనమాట. సీక్వెట్రెంట్స్ ప్రివెంట్ డై అండ్ ట్రైకోవలెంట్ మెటల్స్, copper, ferrous, manganese, calcium, magnesium, etc. from interfering with the chemical processing of the textile material. It prevents catalytic damage of cellulosic fibers. In bleaching, patch during hydrogen peroxide bleaching. Thus, unwanted metal salts cause a lot of problems in processing. Now with focus on minimizing cost and maximizing efficiency, consistency and fastness are two important parameters that every dyer would like to achieve first time. This reduces reprocessing cost, making them competitive. The dryer has to use a suitable sequestering agent in the process wherever it is required. Selection of the right sequestering agent is very important. First and foremost, the sequestering agent should chelate offending metal ions under the given condition and should form a stable complex which does not decompose over a prolonged processing period. Nowadays, many other types of sequestering agents are widely used in textile processing. The three main stages in which sequestering agents are used are pretreatment, bleaching, dyeing. There are some main type of commercial sequestering agents are: number one, amino carboxylic acid base product; second one, phosphates and phosphonates; third one, hydroxy carboxylates, polyacrylates, sugar acrylates. Amino like carboxylates, amino polycarboxylates, it is assumed that one molecule of sequestering agent complexes with one ion of metal depending upon the pH of the medium, that is acidic, neutral, or alkaline. The preferential sequestering order or each product could change. Some of the characteristics of some of the sequestering agents are as below. EDTA, good sequestering agent for calcium and magnesium at alkaline pH, but no sequestering agents on ferrous at alkaline pH, not stable with oxidizing agents, low solubility in acidic medium, NTA. Sequestering ferrous only at acidic pH, but sequestering copper plus 2 between pH 3 to 12. Low solubility in acidic medium, not stable with oxidizing agents. DTPA, good sequestering action Fe plus 3 under alkaline pH. But complexes with alkaline earth salts are less stable than EDTA, slightly more resistant to oxidizing agents, low solubility in acidic medium. Second one, phosphates and phosphonates. These sequestering agents are divided in broad classes: inorganic polyphosphates such as sodium hexametaphosphate, that is SHMP, sodium polyphosphate, sodium tripolyphosphate, sodium trimetaphosphate, sodium pyrophosphates. Phosphonated aminopolycarboxylate such as EDTMP, DETMP, ATMP, HEDP, DTPMP. Inorganic phosphates work under specific conditions and work as sequestering agents by converting troublesome metal ions into water soluble complex by a process of ion exchange. Phosphates of amino polycarboxylic acids or phosphonates are derivatives of phosphorus acid and are characterized by carbon bond, which has stronger hydrolytic stability than the POP bond of polyphosphates. This type of sequestering agent has emerged as a major class of sequestering agent since these possess more features than mere chelation. These characteristics are threshold effect, that is inhibition of precipitation of CaCO3, that is calcium carbonate, CaS over calcium sulfate with substoichiometric quantities of inhibitor corrosion inhibition. Next, resistance to hydrolysis, deflocration, that is stability effect on colloidal suspensions, compared to popular amino polycarboxylic acid based sequestering agents. These phosphonates based sequestering agents have a high chelation ratio apart from better chelation value or better chelation ratio. These phosphonates also have better around chelation than EDTA and NTA. Third one, hydroxy carboxylic acids. Organic compounds that have several hydroxyl groups often have the property of preventing precipitation of bi and trivalent metal cations in an alkaline medium. Some of the well-known products in this category are citric acid, tartaric acid, glycinic acid, and oxalic acid. These are less important sequestering agents compared to amino carboxylic acid or phosphonates, gluconic acid, or sodium gluconate has been found to be an effective chelating agent for iron under alkaline conditions. Fourth one, polyacrylites. Polyacrylites are effective dispersants with mild chelation values and protective colloid properties. The chelation values of polyacrylides have no demetallizing effect on metal containing dyestuffs. They are completely non-foaming. They are very suitable as dye bath, conditioners, soaping agents, and washing aids. Being non-surface active agents, they are easily rinsable and thus reduce the quantity of water required for removing their traces from the substrates. Unlike all surfactants, the typical chelation values offered by polyacrylates do not come closer to the chelation values offered by amino polycarboxylates or the phosphonates. This problem has been overcome by development of sugar acrylates. Sugar acrylates. Sugar acrylates have sequestering values as high as amino polycarboxylates or the phosphonates. They are biodegradable, effective components in cellulosic fabric retreatment during desizing, scouring, bleaching, and mercerizing. These products are characterized by good chelation values from the acidic to the alkaline range and from temperatures of 45 to 115 degrees Celsius. They also exhibit no demetallizing effect on metal content. They also exhibit no ex- they also exhibit no demetallizing effect on metal containing dyestuffs and are non-foaming. They are ideally recommended in pre-treatment for desizing, scouring, and bleaching, and as dye bar conditioners during the cellulosing dye. So sugar acrylates have sequestering values as high as amino polycarboxylates or phosphonates. They are biodegradable, effective components in cellulosic fabric pretreatment during desizing, scouring, bleaching, and mercerizing. These products are characterized by good chelation values from the acidic to the alkaline range and from temperatures of 45 to 115 degrees Celsius. They also exhibit no demetallizing effect on metal containing dyestuffs and are non-foaming. They are ideally recommended in pretreatment for desizing, scouring, and bleaching, and as diaper conditioners during the cellulosing times. Students, we are closing this session. What we have discussed in mainly effect of pH on different textile fibers. So what is the significance of pH? The conditions of the different pH in different conditions of wet processing, that should be different kinds. The pH effect on wool fabric, on dyeing of wool, and also we discussed sequestering agents. What is sequestering agent? Sequestering agent is nothing but the dyeing auxiliaries. So this is used in many wetting process. The sequestering agents are used for pre-treatment, bleaching, and dyeing. So there are many main types of commercial sequester agents are aminocarboxylic acids, phosphates and phosphonates, hydroxyl carboxylates, polyacrylates, and sugar acrylates. So these are we discussed in this session. Thank you one and all. And closing this session.